All right, now we're to the mighty tree. If you have no idea what I'm talking about, it's okay. We can do some math anyway. But anyway, let's move along. So we here have a question which we're going to solve. Find the equation to the tangent to y equals x times x squared minus 3 when x equals negative 2. All right, now the first thing you have to recognize is it's asking me for a tangent. Now what they want is the equation of the tangent line. Now this is going to be a straight line. The tangent line is always a straight line. How do we write the equation for a straight line? Well, most of you are most comfortable with this one. Right? And that's fine. That one will always work. In fact, I'm going to use that one because it'll remind us of some other principles that we need to know. However, you could also write the equation of the line this way. It doesn't specify, so either one of those is acceptable. Okay, I'm going to be using this one, mx plus b, like I said, because I want to review a couple of principles anyway, and I can do that because I'm in charge. I'm the teacher. So here we go. We're going to try for y equals mx plus b. In order to write this, I need two things, and in fact, in order to write either one of these equations, I need two things. I need the slope, and I need a point. Now, in this one, I can use the slope and any point. Whereas in this one, I have to use the slope and the y-intercept, which I can solve for if I have some other pieces of information. Okay? So what we're going to do is we're going to first find the slope, because no matter what, I need the slope. So of course, to get the slope, how do I get the slope of a weird function? I use the derivative. Okay? So we're going to take this, and I need the derivative of y equals x times x squared minus 3. How do I get the derivative of that? Remember, first thing, you got to get it in the right format. Remember, right? Got to get it in that polynomial style format. So I'm going to take this and distribute it in there. So I'm going to have y equals x to the third minus 3x. Now I'm ready to take the derivative. Okay, when I take the derivative, it's going to be dy dx equals, the 3 is going to come in front. So that'll give me 3x. The power is going to go down by 1. So 3x squared minus, and most of you are comfortable with the fact by now that that's 3. If not, watch my other videos. You'll figure it out. It's all right. Okay, so now we got the derivative. Now the question is the tangent. This gives me the slope. Remember, this right here is the slope or the gradient. This is m. But this gives me the slope anywhere along that original function of the x times x squared minus 3. I want the slope specifically at this point when x equals negative 2. So I'm going to put x equals negative 2 in there, much like we did in the last video. And we're going to find out what the slope is at this point. So this is going to be the slope, or dy dx, is equal to 3 times negative 2 squared minus 3. You should be able to work that out. That'll be 3 times 4 minus 3, which is 9. So I got a slope of 9. Okay? So now I've got the slope. I can put that in here. Okay? But even with that, I now have y equals 9x plus b. I don't know the y-intercept. Now, there's various ways that you can get that. One way is to do what we're going to do here, which is to substitute temporarily a value for x and y. Remember, this is just a temporary substitution because x and y have a variety of different values that they can be, but we can use one of them to find the y-intercept. Okay? So the one I'm going to use is I'm going to use when x equals negative 2 because that's the number that they gave me, and so that's the only point that for sure is going to be on this line. First, I need to find out the y value for that. So I'm going to put negative 2 in here. So I'm going to go y equals negative 2 times negative 2 squared minus 3. Note that I put my negative 2's in parentheses to make sure that I square that whole negative 2. So this is going to be negative 2 times 4 minus 3. 4 minus 3 is 1 times negative 2, so that's negative 2. So when x is negative 2, y is negative 2. So I should be able to put those two values in. And then I work it out. Negative 2 equals negative 18 plus b. Add the 18 to both sides, and I get 16 equals b. So there's my b. Now I can put it back into the equation. Remember, x and y were only temporary. The purpose of this was to get y equals my slope, which is 9x plus b. And remember, b is negative, then it'll be a minus b. That's all right. Okay? You got it? That's the first one. That was the easy one, finding the tangent. Now, what I would like you to do is look through my magic kaleidoscope.
Ooh.
you do that, I am going to magically change the question. Ooh, that's so pretty. Oh, there's the new question. Man, that was magical. That was so magical. That's how this whole experience works. That's math for you. All right, so now this time we want to find the equation of the normal. Okay, the normal. What does that mean? That means perpendicular to this graph at the point where y equals -6. Okay, so what we're going to do is we're going to start off with that. Now, in order to find the equation that's perpendicular, remember how to get a perpendicular slope? We get a perpendicular slope by first finding the tangent or the parallel slope and then doing the negative reciprocal. So the first thing we're going to have to do is go find that tangent slope. How do I do that? Well, just like in the previous question, which mysteriously disappeared. Got to make sure my computer doesn't fall off here. Which mysteriously disappeared. Remember, we found the tangent by finding the derivative, so that's how we're going to start here. We're going to find dy dx. Note that this is already in a workable format. Okay, dy dx, take the derivative, bring the 3 in front. So 3x squared plus 3. Okay, now this one's a little bit weird because this says find it at the point where y equals -6. The derivative, I need x. How am I going to get that x value? Hopefully you got it right. You said, well, I got to put that y value into here. And so we're going to put that y value into that function right there. We're going to find out what x is when y is -6. So we're going to think outside the box a little bit. We're going to move over here. Time out. Beep. I'm going to go -6 equals x cubed plus 3x minus 2, and I'm going to solve for x. Now, I'm going to do what any good math studies student would do, which would be to pull out my calculator. Oh, wait, just like most of you, I don't have my calculator out right now. I better go get it. Here's my calculator. So now I'm going to use my calculator to solve for that. You're welcome to try to do it by hand, but I think you're going to have a little bit of a hard time because it's got the little cube there. So let's go ahead, let's solve this on our calculator. We're going to go menu, we'll go down to algebra, and we'll do the numerical solve, and we'll type in the equation. -6 equals x to the 3rd power plus 3x minus 2. See, just like that. Can you see it? Oh, there you go. Just like that, right there. And then remember to put the comma and then the x to tell it to solve for x, just like that. Yep, just like that. And then you push enter. And it says, guess what? X is -1. Man, maybe I should have guessed that. No, probably not. X is -1. So now I know x is -1. Now I can put that in. I can put the -1 into my derivative here. And I can go dy dx is equal to 3 times -1 squared plus 3. So dy dx is equal to -1 squared is 1 times 3 is 3 plus 3 is 6. So that is the slope of the tangent, which is 6. Okay, now remember, we're not looking for the slope of the tangent. We're looking for the slope of the normal here, the perpendicular. So remember, I've got y equals mx plus b. The slope is going to be the normal, the perpendicular, which means I've got to do the negative and reciprocal of this slope right here. So this slope was 6, so now I've got y equals -1/6 x plus b. Okay, and then at this point, remember I now got to solve for b, which isn't going to be all that hard because I'm just going to go ahead and I'm going to take a point in, and I already got a point. Remember, I already got a point because I already solved for x and y in that function right there. So when y was -6, x was -1. So I'm going to go ahead and put that in, plus b. And now I should be able to solve for my y-intercept. I have -6 equals 1/6 plus b. Let's subtract the 1/6, and I get -6 minus 1/6, which is -6.16 repeatings is equal to b. And so I can now write my final equation, which is y equals -1/6x. And if you want the decimal, you can have the decimal. If you don't want the decimal, you're welcome to to write it as a fraction, the fraction would be, let's see, that was 36 over 6 minus 1 more, so 37 over 6. And there's my answer. Now I got the equation. It's perpendicular at that point. No, no problem, right? All right, go ahead and move on to the next one.